Okay, so today we will discuss about network layer. So you are aware that we are discussing about TCP/IP model. TCP/IP model. These are some topics which need to cover down the line. Now we will take up these things one by one. We are here. We have completed a data link layer, and now we have gone into network layer. And network layer we will discuss addressing. Then we will discuss routing. So routing comes in the second next module. I mean the module 4 actually. But we'll time and again jump into module 2, 3 and 4 like that. We'll switch between these two modules. So then we have the transport layer after that. ARP, DHCP and all we'll discuss in this module itself. Then the last two modules contain a lot of things like IP security, all those things. We haven't discussed Wireshark in our class. Wireshark is a tool which we plan to use for the assignments. Those who don't have access to a PC, don't worry. I have an alternative for you as well. We'll discuss. ഇപ്പോൾ കമ്പ്യൂട്ടർ ഇല്ലെന്ന് പറഞ്ഞ് ആരും ടെൻഷൻ അടിക്കേണ്ട ആവശ്യമില്ല. അസൈൻമെൻറ്റ് ചെയ്യാൻ അത് പറഞ്ഞ് വീട്ടുകാരെ വെറുതെ ശല്യപ്പെടുത്തുകയും വേണ്ട. We can understand. Okay. So you can let me know when I announce the assignment. ആ സമയത്ത് നമ്മൾ അങ്ങനെയുള്ള സിറ്റുവേഷൻസ് ആ രീതിയിൽ കൺസിഡർ ചെയ്യാം. We'll have some other alternatives worked out for you. കേട്ടോ? So don't bother. So don't unnecessarily create problems at home. That is what. Already there are plenty of problems probably. So these two people, see this guy looks like what do you say? Both of them look like film actors. Actually, I've seen there somewhere. Anyway, these are two people who are founders of this TCP/IP protocol. We had this guy in our poll a lot of days back, windsurf, the initial polls. Now we don't have polls no longer because all of us are quite busy with this online things. So jumping from one class to the next. So this is also a jump from one network to the other network. So the data from the Alice network, the node has to reach the Bob's PC. So what is that? Is that the Alice application layer, your browser? It's trying to communicate to the Bob's computer, say, and some software. Now the upper layer just passes on its data to the network layer. Network layer does the role of packetizing it, makes into packets and passes into the data link layer. Data link layer makes frames out of packets. So Ethernet is a data link layer, you can say, protocol. Ethernet is something which operates at the data link layer and as well as a physical layer. So per se there is no definition of a data link and a physical link layer. Rather it is the physical link things are left what do you say? They are just not bothered about in the TCP/IP protocol. Actually the botheration comes from just above the data link layer. Okay, because the IP, internet protocol, is really the providing a unique address to a node which is connected to some network. Now when this Alice computer comes to some other network, it will get some other IP. That is there. The internet address is unique. So if you are connected to the network in a college, it will have an IP. But when you carry your computer to your home, it will have some other IP. So IP address is unique. It varies from network to network. It can be used to identify a node in a network, node in a particular network. Whereas the physical address, you say that is the MAC address. MAC address is unique. MAC address doesn't change from one when you move your device from one network to the other network. MAC address is unique. Now as we see here is that the packet is traveling from the network layer to the data link layer. It is made frames. The frames are then sent to the physical layer. Say we will consider it as Ethernet. So bits, zeros and ones are moving through this, and intermediate it encounters routers. Routers will have to examine the packet. It has to examine the packet to find out the destination IP address. It cannot do without that. It has to examine this. It has to undergo the packet. The data has to undergo this decapsulation process up to the network layer in the routers. So that is one thing. So intermediate routers will examine this. So router 4, for instance, it has connections to these 3 networks. So it has to determine to which node it has to send. So all those things are done by means of by examining this IP address. So it will say this is this particular network connected to R7, that is the destination. So it will forward it. Whereas each of these router ports will have different physical addresses. Physical addresses will be different. Also, each of these nodes which are connected to the network. Router nodes connected to the network will have a unique IP also. Okay, you can say a router is a collection of say n ports, each of them having a unique IP as well as a unique physical address, both. That will be a easier way to understand. Now this is transmitted and it is reaching the network layer and above, where it is the decapsulation process again happens, and the application layer gets this thing. So that explains how this thing works. So packetizing is a very important function of the network layer, where you make these things into packets. The data which comes from the upper layer, that is the transport layer, which is the message. The data unit is called as a message. It will be broken down into packets, and packets are sent over the network. There are 2 ways to do that. One is a datagram approach and the other one is a virtual circuit approach. We discussed these details earlier. So datagram approach is what is shown here. Each packet will travel independently of the other. So packet 1, 2, 3 and 4 take different routes to reach the destination network. So now there is some thing who does this task of rearranging these things. All those things we'll examine, we'll take up down the line. The packets are to be sequenced, whether it is the network layer or the transport layer. That has to be very clear. So that is so decapsulation of the packet, all those things are to be done at the network level. So and encapsulating the packet at the sender side, both these things happen there. Now virtual circuit approach is a connection oriented approach, where you set up the connection initially. All the packets will travel the same path from the source to the destination. That is the assumption. Now there is another task. It's a repeat here again. It's a repeat here. I forgot to remove it. So this is routing and forwarding. So routing a packet from the source to the destination. So I mentioned earlier that this is a router. This 1, 2, 3 and 4 are the router ports. So routers will have ports. Each of these ports will have a unique IP as well as unique MAC address. Data comes there. It is verified, checked against the something which is called as a forwarding table. So it will check whether to which. It is just like a post office where it is sorted. Where the different you will say GPO, General Post Office, where suppose I send a post to Thrissur and it gets to the Trivandrum GPO, where it is sorted district wise, same way. So he just checks the pin code, the first 3 digits. Yeah, this is 68680, means this is this postal area, or 682 is this particular postal area. That is well known to the router. So this will have, they have a lookup table like thing. Now this lookup table can be either static, means can be updated real time, or updated what do you say, dynamically, or it can be a static routing table. Both these things could be there. That is all we take up in the routing algorithms, how this routing tables are maintained. So routing tables are routing tables are done updated based on some evaluation which is done by the router. Some evaluation which is done by the router. It will periodically check the status of the link using different ways are there. Different ways are there. It will check using choke packets, like that. Different approaches are there. We'll see later on. So routing protocols also, we'll come across different routing protocol, Dijkstra's protocol, open, shortest path bus, then distance vector, all those things we'll see. All those things are used in the networks, in the internet as we enjoy now. All these things are there to help us go through. Now one important thing is the internet address. So internet address is our 39 people are there in the class, right? I hope all people are there itself in the class. Okay, so it's a 32-bit address, and it's a unique address that defines, I mentioned, it is unique to a particular network to which that node is connected presently. If you are moving from the home network to the college network or a workplace network, the IP will change. That is what the router over there or the network over there assigns you a different IP based on the policies. So and you have a 32-bit address means strictly what do you say, you could have 4 crore or 4 billion, more than 4 billion IP addresses. That is address space, 2 power n, 2 power 32 address space, 2 power 32 addresses. But we'll see that some of things are not to be used as well. So, and this is what our discussion for today, addresses in the internet layer, in the network layer. So as of now we have both two versions, the IPv4 and IPv6, the Internet Protocol version 4 and Internet Protocol version 6. There I am not aware whether there was a operational IPv5, but there might be some intermediate standards which were transitioned, but it was never fully deployed. But IPv4 and IPv6 do exist. But these are the currently existing. We have both these running concurrently as of now. Now you represent your IP addresses either in this form. This is what we are more commonly familiar with, that is in a dotted decimal format. Say something in your college, you will say 192.168.200.227 or 192.168.200.255, like that. You say this is an IP address. So you could represent it as is in bytes, 4 bytes. That is 4 bytes also. That is a binary representation. This is a compact form, and still you have an hexadecimal representation which is used in say network programming and such things. You will use a hexadecimal notation. So the more common, we are more used to this thing, IP addresses with this dotted decimal format. So just have this in mind. You are representing each of these digits with 8 bits, right? You are clear. So let me ask a question. With 8 bits, what is the largest number? All 8 ones means how much? Someone ask answer. Class Parvati, with 8 bits, what is the largest number we get? All ones വന്നു കഴിഞ്ഞാൽ എത്ര വരും?
All ones.
8 ones.
2 raised to 8. Yes, 2 raised to 8 plus. Okay, I don't know.
Don't say like that. I'll ask someone. Jaypal, ആദ്യത്തെ 255 ആണ്, ഏറ്റവും മാക്സിമം വരുന്നത് 255 ആണ്. ഇങ്ങനെ വിചാരിച്ചാൽ മതി അല്ലേ? 255 റൈറ്റ്, 255 ആണ് നമുക്ക് വരുന്നത്. നമ്മൾ 4 ഡിജിറ്റിൽ വി ആർ ഓക്കെ വിത്ത് 4 ഡിജിറ്റ് 8421. അതിന് മേളിലോട്ട് പോയി കഴിഞ്ഞാൽ 1632, 64, 128 like that, right? So that it goes. So all ones and the equivalent decimal. So that is so this is the what do you say, dotted decimal representation. And there are two parts for this address actually. One is what you call as a prefix and the other one is a suffix, right? Prefix could be n bits and suffix 32 minus n, that is the suffix. So the prefix will actually indicate the network. Prefix is indicating the network, and the suffix is indicating the particular node in that network, right? Particular node in the network. So this is clear. That is നിങ്ങളുടെ നെറ്റ്വർക്കിൻ്റെ ഒരു ഐഡൻറ്റിഫിക്കേഷൻ ആണ് ഫസ്റ്റ് n bits. ബാക്കിയുള്ള n bits 32 minus n bits will be the particular node. So there are two types of this addressing actually. IPv4 had a lot of problems, so they didn't think the internet to be to grow such in such a manner, as well as they had a lot of initial hiccups. Say they defined very in a very strict way. They thought that internet would be used only by big companies. People like us won't be using the internet, so they went for a first initial type of addressing scheme which was called as a classful addressing, and it had a fixed length prefix. This prefix length was fixed. Either so you will specify some of these bits in this n bits, some of these initial MSB bits as prefix. Now later on they understood that this is not going to work really, and they suggested some other options, say subnetting and supernetting and all those things were suggested in classful addressing, and that didn't work as expected. Then they shifted to CIDR, classless addressing. So first we'll discuss classful addressing and then we'll go to classless addressing. Now this IETF is something which is working on, this is called as Internet Engineering Task Force, IETF. So IETF is something which is doing a lot of work in this addressing front, and it has these communities, hackathons, all those things. So IETF brings up something which is called as request for comments. Now RFCs for this IoT networks are also having RFCs now. A request for comments, someone will propose something, someone will second something, then they will put it for discussion, comments, all those things. So technical things about the internet. So then if it is then they have some way to approve this and make it a binding standard or sort, so that everyone will subscribe to it. So we need a lot of standardization. Even China has to follow this, or Russia has to follow this. So otherwise they would have to find out ways to connect with the rest of the network, rest of the world. Okay, so this where RFCs 790 and 870, they specified this classful addressing. What they do is that they divided this full address space, that is 2 power 32 address space, into 5 classes: A, B, C, D and E. So the class A addresses would have a prefix 0, class B 10, class C 110, and class D 3 ones and a 0, and class E is a reserved class, that is 4 ones. Now the so that means the big companies, bigger networks will have a class A network. So they will have the first digit as 0, and rest of the 31 bits, that is 2 power 31, theoretically 2 power 31 nodes could be there in that network. here they could have what do you say, 30 2 power 30 networks, 2 power 30 nodes in this second thing. So that is right. No. So this is so this is what you say, that is number of hosts, that is bits. So I was telling the first I was wrong in that, because 8 bits alle, but net id 16 bits were leading bits 10, 16 bits. So number of hosts will be 2 power 14, right? So that is the thing. So that is 2 power 14 and so number of networks is 2 power 14 and number of hosts is 2 power 16, 2 power 16, right? So net id bits. So then again how come this is 2 power 14? Say let's work on this. അപ്പോൾ അതാണ് നേരത്തെ ഞാൻ ചോദിച്ചത്. ഇതിനകത്ത് 0 ക്ലാസ് എ നെറ്റ്വർക്ക്സിൻ്റെ ഫസ്റ്റ് അഡ്രസ്സ് നോക്കിക്കുക, ലീഡിങ് ബിറ്റ് 0 ആണ്. അപ്പോൾ 8 ബിറ്റ്സിനാണ് നമ്മൾ റെപ്രസെൻറ്റ് ചെയ്തേക്കുന്നത്, 8 ബിറ്റ്സ്. സോ ദാറ്റ് ഇസ് leading bit is 0. Say I'll go back to this particular slide again. So 128.0.0.0 to 191.255.255. So that is the number given here. That is the number which is given here. The first byte could change from 128 to 191. Adalle, is it clear? Is that clear? How this works? Hello? Let me ask someone. Say pen and paper എടുത്തു കഴിഞ്ഞാൽ ഇത്തിരി സൗകര്യമായിരിക്കും കേട്ടോ. If you just take a piece of paper and pen, that was really good, because in the S3 class now we do like this. We are drawing K-maps. So we can't teach K-map, all those things, without the board, but we write in real time. So I also write, they also write, and we have it written, things shown occasionally. So this yes, what is the for the class B network, ന്റെ കാൽക്കുലേറ്റ് ചെയ്ത് class B നെറ്റ്വർക്കിൻ്റെ ഒന്ന് എഴുതിക്കേ, ആരെങ്കിലും ഒരാളൊന്ന് എഴുതിക്കേ. What do you get in the chat box? Class B നെറ്റ്വർക്കിൻ്റെ സ്റ്റാർട്ടിംഗ് അഡ്രസ്സും എൻഡിങ് അഡ്രസ്സും എന്തായിരിക്കും? Class B networks. ഇവിടെ പ്രിഫിക്സ് എത്ര വരും? പ്രിഫിക്സ് വരുന്നത് 10 ആണ്. 10 and 3 4 5 6. So that is, this is the first. So this is 128, right? And then ending prefix വരുന്നത് എന്താണ്? 1 1 1 1 6 ones, 7 ones, right? 10 10 and 6 ones, 10 and 6 ones. So that should be 191, right? അതാണ് അതിൻ്റെ. Are you clear? Yes, no, something. What is this? ആരെങ്കിലും ഒന്നൊരു മറുപടി പറയൂ. S8 എത്തിയപ്പോഴത്തേക്ക് ഇത്രയായി. Are you clear on this? Because there might be problems, ന്യൂമറിക്കൽസ് ഉണ്ടാവും, അത് കാരണമാണ് ഞാൻ ചോദിക്കുന്നത്. ഇത് ക്ലിയർ ആക്കിയാലേ മുന്നോട്ട് പോകാൻ ഇത്തിരി ഒരു സൗകര്യം ഉണ്ടാവുള്ളൂ. റൂട്ടർ വിൽ കം ടു ദറ്റ്. റൂട്ടർ അടുത്ത പാർട്ടിലാണ്. നമ്മൾ ആദ്യം അഡ്രസ്സ് പഠിക്കട്ടെ, അത് കഴിഞ്ഞിട്ട് റൂട്ടർ പഠിക്കാം. എടേ ആരെങ്കിലും ഒന്ന് വീഡിയോ ഓൺ ആക്കിക്ക്. ലെറ്റ് മീ ആസ്ക് ദറ്റ് പേഴ്സൺ. Sure. These people are so shy also. Let me pause.